To get ready for our Module 8 test coming up, here are some problems you can do with me. So make sure you have a pencil and a paper. Do these problems with me. Bring them back to class for a prize. So the first ones tell us to evaluate, and that just means to solve, put together what you can. So if we have 2 to the third, we're going to write out that means 2 3 times. So 2 times 2 times 2. So we expanded it. Now we have to find the value of it. We're going to solve. So it's not 2, 4, 6. We're not skip counting. We're doing 2 times 2 is 4 times 2 is 8. So 2 to the third is not 6. It's not 2 times 3. 2 times 2 is 4 times 2 is 8. All right, our next problem, we have 12 divided by 4 plus 6 groups of 18 minus 12. So we have more than one step we need to take, so we want to be sure to follow our order of operation rules. So first we're going to look for those groups. So it says do this first. So we have 18 minus 12. I'm circling what the step I'm on, writing my answer below, bringing everything down. I do that, I expect you to do that. So 18 minus 12 is 6, and I'm bringing this down. Now this is not 66. It's 6 of this, 6 times 6. And then we have plus 4 into 12. So now we have 12 divided by 4 plus 6 times 6. Remember, whenever we can't see a sign, it's of those. We have 6 of these. They're right next to each other, means multiply. So we've done our groups. We do not have any exponents on this problem. So we're looking for multiply and its opposite, divide. Just like we read, we have to go from left to right. So the first one we come to is 12 divided by 4 is 3. So I bring everything else down. So we're still on M. We're looking for those multiply and divide. So this is add. Here we have a multiply. So we have 6 times 6 is 36. Bring down that plus 3. Here we have 39 as our final answer. So we're just funneling down step by step, and we have to do it like we read left to right. Okay, our last one of these practice for evaluate tells us that G equals 4. So anytime we see a G, we just want to plug that 4 in. So we really have 6 groups of 4 squared minus 15.5, close the parentheses, plus G is 4. So we again need to follow our order of operation rules. So we do have a group. So we need to do this problem first. So we have 4 squared minus 15.5, and we still have more than one thing in the group. We have to follow order of operations. So here's our group. We need to do the exponent first, and then we'll subtract. So this means 4 times 4 is 16 minus 5.5. So we need to line those decimals up. We have 16.0, take away 15.5. So we're borrowing here, carrying, so there we have a half, right? Because it's going to be 0 and 0. We have 0.5. 5/10 is a half. We just have half left here. So 0.5. Bringing down that plus 4. And then this is not 6.5. It's 6 of these, 6 of the halves. So we're multiplying that. So just remember, even in our group, we still follow the rules. Okay, so we've done our group now. And the exponent was part of the group, so we're done with exponents. So we're looking to multiply or divide left to right. Here we have 1 here. So 6 times 5 is 30, but it has 1 decimal place, so it's really going to be 3. So if I did the problem out, 6 times 5, that's 30. 1 decimal place, 3.03. If I have a half 6 times, I come up with 3. And I'm bringing this down, so all I'm left with is 3 plus 4 is 7. Just follow your steps. Pay attention to your decimals. Okay, the next topic we have is combining like terms. We're still following our GEMS, our order of operation rules. So we don't have any groups here. We have exponents, but we don't know what n is. This time is just unknown. It could be 19, it could be 12, it could be 3. We don't know what n and r are, so we can't do anything about them. So we have these exponents, but we don't know what they are. So we have multiply problems here, here, and here. Again, we don't know what they are, so we can't do them. So we don't have any divide either. So now we're looking to subtract and add, which is all we have left. Add, subtract, add, add, add. But we can only put things that are like each other together. So I'm going to start with my 5 n's, and I'm going to look for any other n's. Here's one. This is an n squared. This is n. It's different than just 1 n, 8, and r's. So I'm going to take my 5 n's. This is like 1, 5. Take away one of them is 4 n's. Okay, now I'm going to start with our constants, the numbers. So we have the constant of 3. So I'm looking for other constants, just the number. Here's n squared. Oh, here's a constant. So right, I'm just doing some different marks to show that they go together and r's are separate. So this is 3 plus 8. We get 11. And then we have n squared. We have r squared, but n's and r's are different than each other. So we get 4n squared. And then we have r squareds. We don't have any other r squared, so 5r squareds. So we took this, we simplified it down to 4 terms. We have n's, n squareds, r squareds, and the constants. We have the variables of n and r. We have the coefficients, right? Co works together. 4 works with the n, 4 works with the n, 5 works with the r, and our constant 11. So we can only put those things together that are the same. Hey, we can also use the distributive property. So remember that word distribute means to give. So we're going to give this 3 to the 6, but we have to give it to everything, right? This is the truck coming from the Walmart distribution center. It has to go to this Walmart in Brigham, and it has to go to this Walmart in Logan. It has to go to both of them, or they will lose their job if that's where they're supposed to go. So 3 times 6 is 18 with a y. And then we have 3 times 8b. So I have 8 b's 3 times. 8, 16, 24 b's. So don't forget to bring those letters down. So distribute just means give, give. And we can also undo that. This time we don't have anything to multiply, so we can turn around and say, what did they distribute? So we're looking at 8 and 12, and we say, what do those have in common? What can they be divided by? The biggest thing they can both be divided by is 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3, so I'm left with 2 and 3. So now I'm looking, I have C, C, and F. What else do they have in common? They both have a C to pull out. So I'm going to get rid of that and get rid of that because we used it. So if I look here, what's left? Just a 2. And if I look at this one, I'm left with 3 F's. So this is what it started as, and we can give it back. 4 times 2 is 8 with a C, 8 C's. 4 times 3 is 12. C times F is CF. So just back and forth. We're either distributing and multiplying, or we're doing the opposite, and we're dividing and pulling out anything that they have in common. Okay, our next kind of problem is just to simplify. We're not going to know what these variables are, so we just do what we can. But it's important that we still follow our order of operation rules, so follow our GEMS. So if I look at this group, R plus 4, I can't put constants and letters together. So I'm not the same. So I can't do my group. Doesn't have any exponents, so done. It's kind of nice. Lots of things we just can't do. So we're looking to multiply or divide. Well, I can't do 6 times r because we don't know what r is, but I can go times here and times here. We can use that distributive property to give it to everything in the group. It's not going to go to this 8 because it's not part of the group. So 3 times r, if I have r 3 times, I have 3 r's. And 3 times 4 is 12. So then I bring, right? So we did this problem here. We're bringing everything else down. So I have no more multiplying and dividing that I can do. So we're looking to subtract and add. But because we have some variables in there, we can only put things that go together that are common, or yes, combined like terms. So we have 6 r's. We also have 3 r's, 12, and 8. So I can put my r's together, 6 r's, and 3 more. Now we're not multiplying. These aren't r squareds. I have 6, and I get 3 more. I have 9 r's. And then I have 12, and that's a constant. Here's another constant, another number. Take away 8. So I have 12. I'm taking away 8 of them. I'm left with 4. I can't put 9's or r's and numbers together. So that's as simple as we can go. So we have 2 terms, 9 r's and 4. Here's the coefficient. Here's the variable r. Here's the constant. So that's as simple as it can go. So let's try another one of those. So follow GEMS. So every time we write down GEMS. So we have 60's plus 10 or 100 divided by 10 plus 4d groups of d plus 5. Close the parentheses, minus 3 squared. So kind of a long problem, and we want to just shrink that down to the fewest terms possible. So it looks big and overwhelming, but we follow our steps and put together what we can. So we have this group, but I can't put d's and 5's together. Done. Okay, so now we have an exponent here, 3 squared. That means 3 times 3. 3 times 3 is 9. So instead of writing this whole thing again, you can just erase this 3 squared and put 9, just so you don't have to write that big long problem again. So our exponents are done. So now we're looking to multiply and divide. Here's multiply, but we don't know d. Ooh, here's a division problem. We need to do this. So 100 divided by 10 is 10. So we're going to bring everything else down. 6d's plus 10 plus 4d, groups of d, plus 5 minus 9. Okay, so we're still on m, multiply and divide. We said we can't do that. Plus 4d. Oh, here we go. We need to distribute and give this 4 to the d and this 4d to the 5. We have to give to everything inside of there. So 4, and this is right, 1d. So 4 times 1 is 4. D times d is d squared. So when we multiply, right, I could write it 4d. But mathematicians like to simplify it as much as possible, so it's quicker to write 4d squared. And we have 4 times 5 is 20. Don't forget to give the d here. So we had 4 d's 5 times makes 20 d's. So we're bringing down that 9 plus 10 and the 6 d's here. So now we want to, let's check, we're done with multiplying and dividing. We've got add, minus. So we are done with m. So we're on subtract and add. We can only put things together that are like each other. It's going to start looking for d's. Not a d, that's a d squared. Oh, here's another d and a constant. So I have 6 d's and I get 20 more of those. So we're not multiplying, we're just adding on. So they're not going to be squared. I just have 6 and I get 20 more. So I have 26 d's. So now I'm going to start looking for just numbers, the constants. It's a d squared. Here's one, 10 says minus 9. 10 taking away 9 is 1. And then I'm just left with this 4d squared. I don't have any other d squareds. So plus 4d squared. So we broke it down to 3 terms. We just have the variable d. We have this exponent 2, a constant of 1, and then the coefficients work together with the variables. 26 is a coefficient and 4 is a coefficient. So we took this big long problem and simplified it to something much shorter. Just follow your steps, step by step. Don't forget when you distribute to give it to everything inside of that group. That's the biggest mistake I'm seeing, is you would just like to give it to the first one and we don't finish our job and go all the way to the second one as well. Okay, and the last things on our test is just using those variables to write out the problem. Now remember, an expression is not going to have the answer. Even if you know the answer, we don't want it. We just want the problem, just the problem. So Amber earned M amount of money babysitting. So we don't know. She maybe earned $10, maybe she earned $20. Maybe she babysat a long time and earned $100. She bought 4 bracelets that each cost $6. Write an expression to represent how much money she has left. So she started with this money she earned babysitting. We don't know how much it was, but we know it was M. There's our money. And then she's spending that money. She bought 4 bracelets. We got a minus, right? She's spending that money. She bought 4 bracelets that each cost $6. So I'm just going to say, let's say she earned $50. So first, right, I have to multiply. I still have to follow order of operations. And I have to multiply before I can subtract. So she spent $24, 4 bracelets that each cost $6. She spent 24, and I would take that away from 50. She would still have $26 left. If she earned $30, I would take this away, and I could see that she would have $6 left. So whatever M is, I can plug it in and use this problem to see how much money she has left. Okay, and our last problem here says Robbie had $12 in his wallet. He washed cars for $20 each. Write an expression to represent how much money he has after he washes C cars. So right, he starts with 12. And then he's getting more, so we want to add that on. He's getting $20 for every car he washes. So if he washes 1 car, he'd get 20. If he washes 2 cars, he'd get 40. If he washes 3 cars, he gets 60. So we've got this C here. So 20 times C, right? 20, we're just multiplying whatever this is. Now, we don't really want to put a time sign because then it looks like an X. So we can just put 20 C's. So 20 times the cars he washes plus the $12 he already had. You could put that 12 at the end too. It won't make a difference. We can switch things around when we add, but this M has to go in front. We can't minus it at the end because then that's a different problem. So subtracting and division have to go in the right order. If we're multiplying and adding, it's okay if we switch things around. We'll still get those right answers. So when you have this done, bring it back and we will get you a prize.